science fiction has ships zipping all around the universe. While they may be quite different, the one thing they have in common is that there's some way of getting around the cosmic speed limit, light speed. So what is light speed, and why does it get in our way of the exploration of the stars? This is Cultured Science. I'm Mr. E, the science teacher, your host. So this is our introduction video on our series on how different forms of faster than light travel may work in the future. So the basic problem is space. As the Hitchhiker's Guide to the Galaxy says,
space, it says, is big, really big. You just won't believe how vastly, hugely, mind-bogglingly big it is. I mean, you may think it's a long way down the street to the chemist, but that's just peanuts to space.
So you might know that space is huge, but how huge is it? Well, even in our small neck of the woods, distances are immense. The distance between the Sun and the Earth is about 93 million miles. If you were to drive at highway speeds, and let's assume you're from out west where the speed limits are relatively fast, at around 80 miles per hour, it would take 1.2 million years to travel the distance between Earth and the Sun. Or in other words, you could fit 11,740 Earths in the distance between the Earth and the Sun. And of course, distances just get worse going from star to star. The distance between Earth and its nearest star, which is Proxima Centauri, is this ridiculously huge number here. Even the Parker Solar Probe, the fastest thing that was ever made by humans, which travels at a blistering 153,545 miles per hour, would take 18,356 years to get to Proxima. Just note that human history is only a couple of thousand years long, so this would be much longer than all of recorded history. So because these distances are so immense, scientists came up with the unit of light years, because it's way easier to say Proxima Centauri is 4.2 light years away than this huge number. Light years are the distance that light travels in a year. So it's a unit of distance, not time. They chose light because it's the fastest thing in the universe, which we'll get to later, at this huge number here. And because it's the fastest thing, it carves out a large chunk of space to be useful on interstellar distances. By the way, there are also distance units called light days, light minutes, light seconds, etc. For example, the Sun is approximately 8 light minutes away from Earth, so the light you see from the Sun left 8 minutes ago. For reference, the Moon is about 1 light second away, and the edge of the entire solar system is only 1 light day. That just goes to show how ridiculous things are on the interstellar scale if the entire solar system is just 1 light day and the nearest star is over 4 light years away. So that's one of the main reasons why science fiction needs ways around light speed. After all, the plot would take forever if it took
2,000 years later
to get to the next star. It just wouldn't be worth it. However, though, it's actually worse than that. One of the weird things about physics is that the faster an object goes, the more its effective mass is. I know that's weird, but basically the faster you go, the more energy you have to put in to make it go faster. It's a classic logarithmic curve. And when eventually you do hit light speed, you basically need an infinite amount of energy. Anytime in physics when you do the math and it starts spitting out infinities, you know that it's impossible. Well, either that or you did the math wrong, but in this case, it's definitely impossible. So nothing with mass, that is stuff, can go faster than the speed of light. And even if you could travel at light speed, you wouldn't want to for 2 main reasons. The normal equation for kinetic energy is E equals mv squared, with m being mass and v being velocity. However, in this case, our velocity, v, is the speed of light, which scientists note by the letter c, And if you do the replacement in the equation, you get that most famous equation, E equals mc squared. Basically, energy is equal to mass times the speed of light squared. So basically this implies that when you hit something at the speed of light, all the energy in that matter would be released. It's basically the equivalent of getting hit with antimatter. You might go, so what? But only 700 milligrams, or about a third of the mass of this dime here, was enough to wipe out Hiroshima in a nuclear blast. So imagine that every time you hit something. And while space is mostly empty, it isn't entirely empty. There's still, specks of dust, random gas molecules floating around, and, God help them if they should hit a rock. And of course, traveling at light speed, you would be covering massive distances in space, so it'd be just like if you were steering the ship through a fog of antimatter. Your ship itself will be worn away from the constant collisions, not to mention the extreme amounts of radiation that would be released from all the collisions. Basically, everyone would die. Then there's the problem of time dilation. While it may seem weird, the closer you get to light speed, the wonkier time becomes. So you go out on your
5-year mission to explore strange new worlds, to seek out new life and new civilization,
and come back to find 35 years has passed, everyone you know is dead, and they've totally forgot about you. In the simplest terms explaining time dilation, although time passes normally for you, the act of traveling at extreme speeds caused the time experienced by you and everyone else to flow differently. We actually see this all the time in satellites. Because they're at a higher altitude than us here on the surface, they have to travel faster to get around the Earth, and because they travel faster, their clocks tick ever so slightly differently from ours. All of our modern GPS and satellite communication would totally ground to a halt if we did not take time dilation into account when we're communicating with them. Now obviously, time dilation is way more complicated than that, and probably deserves its own episode if I ever get over the high level of physics. Oh, physics, I love you, but you melt my mind. So, taking into account that we can't do light speed, and even if we did, it would probably be deadly, we need a way around it. So stay tuned for next episode, where we will try to figure out ways around the light speed barrier and see what can happen. So if you like this video, please remember to share and subscribe. Also, if you have any topics that you think need sciencing, please write them in the comment section below.